We know there are three ways to prove two triangles similar: angle, angle, side, 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 and side, angle, side. On number 10, no angle information is given, so we need to try side, side, side. We want to form ratios of corresponding sides and see if they're equal. So we're going to take the smallest side of RQP and divide it by the smallest side of MNO. That's 7 over 21. Find the middle sides and divide them. That's 10 over 30. And take the largest sides and divide them. That's 15 over 45. Those all reduce to 1/3. So triangle QRP is similar to triangle NOM by angle, angle. Notice that if I do call the first triangle QRP, I'm going down the short side and then the long side when I say the letters QRP in that order. I must take the same trip around the other triangle, and if I go short followed by long, rather, I'm going to have NOM by angle, angle. On number 12, there's no similarity here. The sides are in the right ratio, they equal each other, they are proportional, but we don't have the correct angles to apply angle, angle. We would need the two angles I've circled in green, angle E and angle I, to be congruent to make the triangle similar by side, angle, side. But as they're sitting, they are not similar. On number 14, the triangles are actually congruent by side, angle, side, and if figures are congruent, then they are also similar. So triangle STU is similar to triangle XVW by side, angle, side. On number 16, due to the parallel lines, the angles at A and B, which are marked with 2 marks in the diagram, are congruent to each other because they are corresponding angles, and also the angles at E and D with the 1 marks on them are congruent. The triangles also share angle C, so the two triangles EAC and DBC are similar by angle, angle. On number 18, due to the parallel lines, we have alternate interior angles. Angle E is congruent to angle D, and angle A is congruent to angle C. So the triangles are congruent by, are similar by angle, angle. If we cross multiply and solve here, well, let's set up our proportions first. We're going to take 5 over 3. Now we're taking 5 over 3 because they're between the same pair of angles. They're between the angles I've marked with 3 marks and 2 marks, and set that equal to x plus 3 over 2x minus 8. We'll cross multiply and solve, getting x equals 7, giving the length of AB then as being 10 and the length of BC being 6. On number 19, due to the parallel lines, again, we have corresponding angles congruent. The angles at E and D are congruent. The angles at B and C are congruent. So our triangles are similar by angle, angle. Forming ratios of corresponding parts. First of all, AE is 8 minus 5 is 3. Now I'm going to take AE, the 3, and divide it by the corresponding part in triangle ADC, which would be the 8. I'm going to set that equal to x plus 2 divided by the corresponding side in the big triangle, which would be x plus 8. The x plus 8 comes from adding x plus 2 plus 6. So when I solve that proportion, I get x is equal to 8/5. That makes AB 3 3/5 and AC 9 3/5. On number 20, the technique I think we need to use here is to draw the two triangles which overlap separately. I've done that in the bottom right-hand side of this diagram, and we can see that they're similar by angle, angle. So, forming ratios of corresponding parts, the 3 corresponds to the 8, and the x minus 1 corresponds to the x plus 2. We get the proportion that is shown over here on the left side. We cross multiply and solve. We get x being 14 over 5, which then gives us that BD is 9/5 and CE is 24/5. On problem number 21, again the technique, and I've drawn the triangles in the bottom left hand of the picture now, is to draw the two triangles separately. Each triangle contains angle A and a right angle, so they are similar by angle, angle. Forming ratios of corresponding parts then, we get 6 over 9 equals x over 12, which gives us an x value of 8. 8 then is the length of AS. The length of AB is 8 plus 7 is 15. On the pyramid problem, problem number 32, the ratio of the height of the pyramid to the height of tallies divided by the distance along the ground, which would be 239 feet for the pyramid and 3 for the length of the shadow, we form the proportion then h over 2 equals 239 over 3. When we solve that, we're going to get that the height is 478 over 3 paces. Since each pace is 3 feet, I'll multiply that by 3 and get my answer to be the height of the pyramid at 478 feet. On our surveying problem, there are actually 3 right triangles in this picture. 2 of them contain angle M and a right angle, so they are similar to each other, and 2 of them contain angle P and a right angle, so they are similar to each other. Since similarity is transitive, all 3 triangles are similar to each other. We're going to use the 2 on the outsides of the picture here, the 2 I boxed in green, and form ratios of corresponding parts. Letting x be the length of PK, we get 4.5 over x equals 1.5 over 4.5. Cross multiply and solve, and that gives us the length of KP, which is the distance along the stream from point K to point P, to be 13.5 feet. On problem number 41, again we have similar triangles. The light reflects out of the mirror at the same angle that it comes in. So we have 2 similar triangles here. We'll just again form ratios of corresponding parts. Height over height equals distance along the ground over distance along the ground. So that's 1.92 over x equals 0.4 over 87.6. Cross multiply and solve, and the height of the tower is around 420 meters. Over on page 313, we're using the fact that a line which is parallel to one side of a triangle, and you see a little picture in the top left corner here, a line parallel to one side of a triangle divides the other 2 sides proportionally. That is, in terms of the diagram in green up here, A over B equals C over D. So on problem number 14, we have a setup for that. We have MN is parallel to YZ, so it must divide XY and XZ up into parts that are proportional. Letting the length of MY be X, then we get 4 over X equals 6 over 9 from the given information. Cross multiply and solve. X is 6, which means the length of XY is 4 plus 6 is 10. On problem number 15, I've redrawn the picture below number 15 on the bottom left-hand side of the picture here. Put in all the given information. We have to do a little subtraction to get the length of MY. 10 minus 2 leaves us with 8. And since MN is parallel to ZY, it divides XZ and XY proportionally. That gives us the proportion 2 over 8 equals T minus 2 over T plus 1. We cross multiply and solve, and we get T being 3. On problem number 16, we've got a perfect setup for the proportionality theorem. The left sides of the triangle and the right sides of the triangle are divided proportionally. X over 24 equals 3 over 18. Cross multiply and solve. X is 4, and therefore the length of AD is 4. Again, a perfect setup in number 17. We will say that 3 over 2x minus 3 equals 2 over 6. Again, cross multiply and solve, giving us x equals 6. The length of ED is then 9. On problem number 18. After putting the given information there, we've got that 16 over 20 is equal to x minus 3 over x plus 5. Cross multiply and solve. X becomes 35, AC is 32, and CD is 40. Problem number 19, we've got to do a little more work here. On problem number 19, we're going to have to use the triangles twice. We're going to use line BF first. It divides AC and AE proportionally. That gives us the proportion in red there, that 6 over x, where x is the length of BC, equals 8 over x plus 10/3. When we cross multiply and solve, we'll get an x value of 10. That tells us that the length of BC is 10. It also gives us the length of FE at 40 over 3. Now, we're going to use the line that I've highlighted in purple there, FD. It's parallel to AC, so it divides EA and EC proportionally. That gives us 2y minus 3 over y equals 40 over 3 minus 8. We cross multiply and solve. Y is 9, and if y is 9, that means that CD is 9, and DE is 15. On problem 33, finding y is easy. The two segments with the y's in them are marked congruent, so we just set them equal. 3y minus 9 equals 2y plus 6, and we'll have y equals 15. We're going to use the mid-segment theorem on the second half of the problem. The mid-segment theorem says that when you connect the midpoints of two sides of a triangle, you're creating something called a mid-segment. The length of that mid-segment is always half as big as the third side. So whatever the mid-segment is, we'll just double it and get the third side. So if I take 2 times x plus 2, that will give me the 5/3 x plus 11, which is the third side. Solving that, we get x being 21. On problem number 34, they've made this problem easy. The theorem says that when we have 3 or more parallel lines, that they divide all transversals proportionally. Well, in this particular case, the proportion is 1 to 1 because they've marked that each of the transversals are divided into congruent segments. That makes this problem really easy. We just set 2x plus 3 equal to 6 minus x and get x being 1, and we set 2y equal to 4/3 y plus 1 and get y equals 3/2. On problem number 43, the lots all have boundaries, vertical boundaries here, that are parallel to each other because of the right angles. Since all of them are parallel, the segments representing the frontage along the road and the frontage along the lake must be divided proportionally. Now, one way to look at this is that the ratio of the length along the road to the total length along the road, which we can add up, and it's 113, has to equal the length along the lake shore, which we don't know, divided by the total length along the lake shore, which is given in the problem to be 135.6 meters. So, for instance, as we're trying to find u, I will take 20 over the 113, and that's going to equal u over 135.6. And similarly, I can solve for each of these guys, and you get the amounts shown for u, w, x, y, and z.